All right, folks, welcome to your Calculus Chapter 3, Quiz Number 1 review. On this page, I've got the answers. I've written out the original question. So number 1 on your quiz review, 7x minus 2/3 x to the third. You're simply going to use the power rule. Just bring down the power, 1 power less. All right, 2/3 times 3 is x or 2x squared there. Let's keep going here. Number 2, that's simply the power rule. That should be no big deal at all. Again, call it f prime of x. There's the answer. Not much work to be shown. Number 3, I just showed that when you multiply 10 by 2/5, bring down that power, you get 4, and then 1 power less, 4x to the 9th. You want to see that one as well. Number 4, I suggest that you rewrite that as negative 13x to the negative 4th. Bring down the negative 4. Negative 4 times negative 13 is 52x to the negative 5th. Put x to the 5th in the denominator. Number 5, you could use the product rule, but honestly just FOIL it and then use the power rule. It's just 6x minus 10 when you take that derivative. All right. I would rewrite the 7th root of x to the 3rd as x to the 3/7. Bring down the power, 1 power less. Then, okay, so this is when, I just rewrote it here. This is when we take the derivative, bring down that power, 1 power less, and then write both the negative powers in the denominator there. Number 7, folks. It's not looking too clear. Hopefully that will refocus. Divide both those terms by x to the 4th. That's 3/2 minus 4, negative 5 over 2. That's 1 minus 4, negative 3. So then use the power rule. Bring down the power, 1 power less. Bring down the power, 1 power less. Write those negative powers in the denominator. All right, number 8, just distribute there. X to the 3/4 times 3x to the 1st is 3x to the 7/4 minus x to the 1/2 times x to the 3/4 is x to the 5/4. Then use the power rule. Number 9, you could use the product rule, derivative of the first times the second plus the first times derivative of the second. You do need to have that down for tomorrow's quiz, or you can just distribute it and then take the derivative. Whatever you want to do there on 9. 10, you definitely need to use the quotient rule, all right? You have low derivative of the top, so low d high, minus high d low, derivative of the bottom, all over the square of what's below or the denominator squared. These are conjugates right here. Make sure the negative goes through to both products there, and it will simplify to give you that. And that's it for 10. So that's a quotient rule question, being able to do that. This one I wouldn't, you don't need to do the chain rule. You could bring down the 2, rewrite that, multiply it by negative 7. You'll still have to distribute anyway. Why don't you just FOIL it and then take the derivative, all right? You don't need to use the chain rule on this quiz. You can if you want, but you don't have to. All right, here you could do the product rule, but you have to clean it up quite a bit because that's a really simple answer. Look at that derivative. This is actually how you would factor the difference of perfect cubes. So if you just distribute, you get this and then take the derivative of that. You could use the product rule, but you could just distribute. It cleans up really nicely, and then that's the derivative. Find the equation of the tangent line to a given curve at a given point. Just take the derivative. All right, so you can write it as f of x if you want. I think it was the square root of x. I wrote it as x to the 1/2. Bring down the power, 1 power less. You really need to write it like this, 1 over 2 times the square root of x, and you plug 16 in for x. Square root of 16 times 2 is 8. That is the slope. So it's y minus y1 equals the slope times x minus x1. 14, very easy derivative to take. 4x minus 3x squared. Plug 3 in for x. You get a slope of negative 15. You got y plus 9 equals negative 15. X minus 3. All right, on 15, you have 4x to the 3rd plus 6x minus 5. Plug 1 in for x, and you get a slope of 5. Number 16, take the derivative. You get 8x plus 2. Plug 2 in for x. Again, you're always plugging in the x coordinate. Always plugging in the x coordinate. All right, there's your equation. Then on 17, take the derivative. Plug negative 1 in for x. X plus 10 is 13. X or y plus 10 equals 13x plus 1. 13 is your slope. All right, and then I believe 18 is the last of those. Do have to use the quotient rule, low d high minus high d low, all over the square of what's below. Notice how the two x's will cancel. Make sure to distribute that negative to both terms on the right side. Got negative 7 over x minus 2 squared. Plug 3 in for x. Slope is negative 7. All right, on 19, whether it's s of t or s or h of t, the first derivative is always velocity. The derivative of the position function is always velocity. So just take the derivative and really just plug in 2.5, 4, 1.5, and 1 for t in all those equations. 25 feet squared, negative 23, 57, 73. Again, if it's going up, positive, going down, negative. I want you to be bad at all. That first derivative is negative 32t plus 105. Now on 20, you're given s. Take the first derivative, it's velocity. The second derivative, it's acceleration. So that's what it means when it says, like, give the state's acceleration and velocity as functions of t. There it is. First derivative, and then take the derivative of velocity to get acceleration. I forgot to plug 2.5 in there, but I believe that's 6 1/4 times 12. What is that? 75 minus 45. I think it's 48. Anyway, use a calculator for that. 48. What is it? Meters per second squared if it says meters. This next one also don't have an answer there. That should be 108 minus 81. 27 plus 24 is 51 minus 7. That should be 44 meters per second, possibly. All right, that's number 20. Then the next few, you have to take both the first and the second derivative. Take the first derivative of that. Negative times a negative on the power rule gives you a positive, x to the negative fifth, so write it like that as your answer. Then you could use this original one to find the second derivative. So bring down the power, 1 power less, that's how I got that. And then write it over x to the sixth. 22, I would not use the quotient rule. Instead, I would divide everything by x to the negative 3/2. 3/2 minus a negative 3/2 is 3. 2 minus a negative 3/2 is 7/2. Then take the derivative. All right. When you use the power rule for the second derivative, 5/2 times 35 over 2 is 175 over 4, 1 power less. 23, I would FOIL it first, then take the first derivative, and then take the second derivative. No big deal there. 24 is pretty self-explanatory as well. Just take the first derivative, power rule, and then do it one more time. Should cause no issues. Now, you only need to take the first derivative on 25. We'll divide everything by x to the 1/2. So it's going to be x to the 3/2 plus 3x to the 1/2 minus 2x to the negative 1/2. Again, you can do negative 2 divided by x to the 1/2. Just put x to the negative 1/2 right by the negative 2. Then use the power rule. All right, and then rewrite that. If it's got a negative exponent, put it south. That is 25. All right, here on 26, I would divide everything by x. Then low d high minus high d low over the square of what's below. Make sure to distribute that negative through. You're going to be left with a positive 7 up top over x plus 5 squared. And then lastly on 26, you could do the product rule. Derivative of the first times second plus the first times derivative of second. I just did distribution first and then cleaned it up and then took derivative of that because it's an easy power rule. All right, folks, this is your quiz review for your quiz tomorrow. Yak Math Videos signing out.